Today we will learn about non-linear 2D stress analysis. As you can see that we will also perform this beautiful simulation in our today's tutorial. Hope that you are doing well, and if you didn't subscribe my channel, then subscribe it so that we can grow each other. First of all, save this file with the name of sheet metal bending simulation and save. From here I'm selecting the front plane and make it normal. Just go to the sketch and select center rectangle from here and give dimensions to this, as this one is 55 mm and this one is 70 mm. Press OK, and from features select extrude boss base, and from here select the mid plane and give this thickness as 35 mm. Press OK. Now again select the front plane, make it normal, and sketch a corner rectangle here. I'm selecting this point and give this dimension as 20 mm and this one as 80 mm. Press OK again. From features select extrude boss base, and from here select mid plane and here select the merge results so that these two bodies will be merged to each other. Press OK, and from here I'm selecting the background as white plane, and here I want to give a radius here to this edge of 5 mm. Select fillet and from here give the value of 5 mm, and items to fillet select this edge. Press OK. Now this is our die and save this. And now here I want to make a pressure pad, and again select front plane and sketch this and select corner rectangle and go to smart dimensions and give this dimension as 1.2. OK, and this dimension as 25 mm and this one as 55 mm. Just escape from the smart dimension command, select this line, press Ctrl button from the keyboard and select this line, make it collinear. Now it is fully defined, and from here select extrude boss base and unselect the merge results because these are two separate bodies, and from here select the mid plane and press OK. Now I will again give our radius of 5 mm to this edge. Select this edge and put this value as 5 and select OK. Now this is our pressure pad. Now we will draw a punch here, and for this again select front plane and sketch this. From here I'm selecting the corner rectangle and give dimensions to this, as this one is 30 and this one is 75 mm, and from here select this line, press Ctrl button from the keyboard and select this edge and give this dimension as 1.3. Press OK, and again from here select extrude boss base. From here select the mid plane and unselect the merge results and select the mid plane from here and press OK. Now I want to give radius to this edge and its opposite edge, this one and this one. Press OK from here. Now this is our punch. Now we require a sheet here. For this just select the front plane and sketch this, and from here select the line and draw a line here and give this dimensions as 100 mm, and this one, press Ctrl button from keyboard and this edge, select this and give dimensions to it as 1.1, press OK, and now just go to extrude boss base, or from here select this as 35 and unselect the merge results. From here select mid plane, and this, the thickness of our sheet is 1 mm, so I'm selecting 1 and press OK from here. It is not fully defined sketch, then edit sketch this, and from here select smart dimensions and select this one and this one and give this dimension as 4 mm. Okay, now press OK and exit from this. Now this is our sheet, and this is our die, this is pressure pad, and this one is the punch. Now we will just perform the simulation to this, and from here if the simulation tab is not visible to you, then just press on the SolidWorks add-in, and from here select SolidWorks simulation. Now this tab will be added here like this. Here is the simulation tab, and if you don't now to add simulation tab from this method, then you can also add from by right clicking on it, and from here just select simulation from here, and this simulation tab will be added here. Now drop down it, and from here select the new study, and from here select the non-linear that I have selected this one, and from here select the use 2D simplification. Why I am using 2D simplification? Because if we perform simulation in the 3D, then it will take a larger time, so that is the reason I'm selecting the 2D from here, and so that we can obtain our results in a few minutes, and press OK. And from here select the section plane or section depth. Section plane, here I'm selecting the front plane. Why I'm selecting the front plane? Why I didn't select the top plane or right plane? Because we draw our whole geometry in the front plane, and our whole body is symmetric in the front plane. If I select the top plane, then it is not symmetrical, and if I select the right plane, again it is not symmetrical. It will be only symmetry in the front plane. So I'm selecting the front plane here, and from here select the depth of 50 mm, press OK. Now here just drop down it, and here this is our punch, this one is pressure pad, and this one is our die, and the last one is our sheet, and give materials to these all surfaces, and I'm selecting these, and from here go to apply favorite material, and from here I'm selecting plain carbon steel, and for the sheet I'm selecting the 1060 alloy, and if you select the cast carbon from here, then it will not suitable because it will crack. So it depends on your choice which material you select, and from here make it normal, and just right click on it and select the contact set, and from here select no penetration. Why we select the no penetration? Because we want to see the results of the deformation and if there will be any penetration, then our results will not be clear to us. Now from here just select these edges and then select this one and select this edge and press OK. Before pressing OK, just select the friction and from here select advanced, drop down it, and from here select surface to surface. Why we select the friction here? Because without friction the simulation will not turn up the mark, or we want to study the simulation results here. For this the friction play an important role here, so we just selected the friction here, and from the advanced we select surface to surface, because this contact will be surface to surface. Press OK, and again contact, and here select this one and select from here, delete this, select this and select this one, and this edge, press OK. Again select this edge, and from here select this edge, and this edge, select friction, select advanced and press OK from here, and just drop down it, and from here edit definition, and we didn't add the friction, and this one here, press OK. Now select on the fixtures and fixed geometry, select this edge, this one, and this one, press OK. It means that our this body will be fixed. And again from the fixtures select fixed body and select this edge here, press OK. Now again from the fixtures select fixed geometry, and here select this one, and press OK. Also this one, press OK, and again select fixed geometry and select this edge, and from here drop down it, and here select this one as 0 and just drop down it and select this one as 90, and from here you can see that this one is in the above direction, we want it in the below direction. From here I will just select the reverse direction. Now it has been reversed, and press OK from here. Now zoom to fit, and just select the mesh, and from here create mesh, and just increase this value and press OK from here. Now mesh has been created, and just run this study from here. Now just ignore this, and here our results is calculated. As you can see that this is our punch and this is our sheet, and it will bend it and will show the results of stress analysis here. Now here you can see that it is just bending this sheet. it has been completed here, and just wait it. Now it has been completed, and if you want to see the results in 3D, just right click on it, and from here select show as 3D plot, and from here you can see this 3D plot from here. And if you want to see the graph, and then just drop down this plot tools, and from here select probe, and here select the points where you want to see the results. Like I'm selecting this point, then this point, then this point, and then this point, and from here these points are selected, and just drop down it, and from here select on the plot. So these are the results of von Mises stress, and these are the nodes that we selected. In this way you can obtain the graph, and you can use these values in your research or research projects. Just select OK. Here if you want to see the strain results, then just double click on it, and here you can see the strain results. And if you want to see the displacement, then just double click on it, and the displacement results will be shown here. And if you want to download the report of this project for your research, then just click on the report, and from here just publish this. Why we download the report? We download this in order to see our loads, forces, and average stresses, maximum stresses, which material we use in our die, in our like which you want to know. All the things can be obtained from your report that will be downloaded from here. I will show you when this report will download. All the values and all the things that we done in this project will be written there with the pictures and with the simulation results. These are all the work that we done, and now the color are changes and the results are changing because it all writing on our report like this. Here it is opening and it has been downloaded. Here this is the project name that we give to this, and here this one is our geometry, and from here you can see that the section depth, weight, volume, and from here you can see the mesh type, the end time, and from here you can also see the Poisson's ratio, shear modulus, thermal expansion coefficient of this component, and here all the things are given like forces, which forces applied, and here are the simulation results. Like this is the mesh, and the nodes will also be written here like this one. The total number of nodes are total elements are also given there, and these are the simulation results. And from here you can obtain these pictures for your research project. So this was all about today's tutorial. If you didn't subscribe my channel, then subscribe it so that we can grow each other, and we will meet in the next video.